So let's talk about the heart. Your heart is a pumping organ and is capable of two circulation, no? Two pumps. First is your pulmonary circulation. Okay, this comes from the right side of the heart and it carries blood towards the lungs, where carbon dioxide diffuses from the blood into the lungs and oxygen diffuses from the lungs into the blood. And then the blood is carried back to the left side of the heart, and this is now responsible, no? The left side is responsible for your systemic circulation. So once the left side of the heart pumps via your left ventricle, it delivers oxygen and nutrients to all the remaining tissues of the body. Heart functions to generate blood pressure. So this is facilitated by the heart's contractions or pumping, no? So that's the one responsible moving the blood through the vessel so it could reach the target organs and tissues. Okay. Second function is that the heart routes the blood. It separates your pulmonary from your systemic circulations, and your blood ensures one-way blood flow, no? One way because of the valve's heart. So there is no mixing of oxygenated and deoxygenated blood, no? And the fourth one is the heart regulates blood supply. So by adjusting its rate and force of contractions, no, it it is adapting to the various metabolic needs of a certain situation. For example, if you're exercising, your heart would pump faster than when you are in a relaxed state. So your heart is shaped like a blunt cone and is approximately the size of a closed fist. Now, this part here is what you call your apex. This is the rounded point of your heart, while the other opposite end of the heart, which is a larger part, flat part, is what you call the base, no? And the heart is located in your mediastinum. So this is a midline portion of your thoracic cavity that also contains your trachea, the esophagus, your thymus is also here, no, in this mediastinum. And there are a lot also of other associated structures. Surrounding your heart is your pericardium. So this one, that's your pericardium. Yeah. It is also called as your pericardial sac. This is a double-layered closed sac that surrounds the heart. There are two layers of your pericardium. The outer pericardium is your fibrous pericardium, while the inner layer is called your serous pericardium. So in this case, here is your fibrous, no? The yellow portion, the outer layer, while the inner portion is your serous pericardium. Now you see two more layers, no? Because your inner serous pericardium is actually made up of two more layers. I will explain later. But let's focus to your fibrous pericardium, which is the outer layer. This is a top fibrous connective tissue that prevents the overdistension of the heart, and this anchors the heart within the mediastinum. Now, superiorly, no, this fibrous pericardium is connected to the coverings of your great vessels, no, your artery, your aorta, and your pulmonary trunk. While inferiorly sa ilalim, this is attached to the surface of your diaphragm. So dito, this is your diaphragm, no? And this fibrous pericardium inferiorly is connected to the surface of your diaphragm. So in this picture, you will see more clearly, no, the two serous pericardium. The viscera is the red, and the parietal is the blue. One in between is the cavity, no, filled with your pericardial fluid. The walls of the heart has three layers. Starting from the most superficial layer is your epicardium, and then the second layer is the myocardium, and the innermost layer is your endocardium, no? S1, endocardium, myocardium, and your visceral pericardium, also known as your epicardium. This is the superficial layer of your heart wall, no? Itong epicardium. Deep to that, which is a thick middle layer, is your myocardium that is mostly composed of cardiac muscle cells, no? Ito yung portion na to is this wall is the main contracting muscle, no, of the heart, okay? And then the inner portion here is your endocardium, which forms the smooth inner surface of the heart chambers that allows blood to move easily through the heart. As mentioned, the inner layer is your serous pericardium, no? So let's see, where is your serous pericardium? This one is fibrous pericardium, and these two layers actually here are your serous pericardium. This has two parts, no? That's why you see two layers. You have a parietal pericardium, the blue lining, and a visceral pericardium, the red lining that is directly attached to the surface of the heart. So your parietal pericardium is the one that lines the fibrous pericardium, while the visceral pericardium is the one that directly covers the surface of the heart. This is also known as your epicardium. Now, between these two layers, you would see a space, no? A small space. That space is called your pericardial cavity. So this is separating the visceral from your parietal pericardia. And inside this space is a fluid, which is called your pericardial fluid. The fluid here would reduce the friction as the heart pumps, no, it moves within the pericardial sac, and that fluid helps, no, reducing the friction. So there is an emergency procedure, no, a life-saving procedure, but that we call your cardiopulmonary resuscitation, or CPR. This maintains blood flow in the body in case the person's heart stops. Okay, it consists of firm and rhythmic compression of the chest combined with your artificial ventilation of the lungs. So it's a life-saving process. As a nurse in the future, you will have to learn this one, and this requires proper training, no, for correct execution. So this is the external anatomy, no, of the surface of the heart. Your heart consists of four chambers. You have two atria and two ventricles, okay? Your two atria, which are your right atrium and your left atrium, they are both thin walled, no, and they are located, and they are more located superiorly and posteriorly of the heart, while your ventricles are thick walled and they are more anterior and inferior of the heart. The blood from the different parts of the body enter your right atrium first, no? By way of large veins. These are your superior vena cava, this one, and another inferior vena cava. So both of them drain the blood towards the right atrium. You also have what you call a coronary sinus. They empty also the blood towards the right atrium. Your coronary sinus are small vessels which carry, no, the blood, no, sa mga vessels in your heart. They also empty towards your right atrium. So as your right atrium pumps blood, it moves to the right ventricle, okay, via a valve called your semilunar valve. No, atrioventricular valves. And when this right ventricle pumps the blood now, it leaves the ventricle by way of a pulmonary artery. No, pag pump niya, this is your pulmonary uh, artery. Okay, this one there are, okay, these are your artery. They, these are blue because they are unoxygenated blood pa ito, no? So there is the branch of your pulmonary artery, apat yan, and they carry the blood toward the lungs, okay? After gas exchange happens in the lungs, no, oxygenated blood is carried back to the heart by way of your four pulmonary veins. That's why they are red, and they empty to your left atrium. Okay, dito na portion. So, once the left atrium now pumps the blood towards your left ventricle, no, then the left, by way of another, no, same atrioventricular valve, then your left ventricle would pump now the blood towards your aorta, going to the entire system and organs of the different parts of the body. So your aorta and your pulmonary trunk, no, they are really big vessels, as you can see in this picture. Okay, because of their large size, these are referred to as your great arteries, no, your pulmonary trunk and your aorta. The heart has four chambers. You have two atrium, a right atrium and a left atrium, and you also have two ventricles, a right ventricle and a left ventricle. So let's talk about your right atrium first. Now this one. Your right atrium has three openings to it. The first one is this opening from the superior vena cava. No, this is your superior vena cava, and an opening from an inferior vena cava, plus the third one is an opening from your coronary sinus. You see a small opening here. So your vena cava, superior and inferior, they carry the blood from the body, no? And while your coronary sinus carries the blood coming from the heart, so they all drain to the right atrium. While your left atrium has four uniform openings. So let's see. Your left atrium is here. The four uniform openings are coming from your four pulmonary veins. No? This one, the left pulmonary vein, and you also have a right pulmonary vein. Okay? This vein is carrying blood coming from your lungs. So this left atrium actually receives oxygenated blood already from your lungs. Your right and left atrium are separated by what we call an interatrial septum. So it's here, no? Your interatrial septum in between your right and left atrium. And in this right side of your interatrial septum, you will see what you call a foramen ovalis. It's actually a depression. So let me see if you can see it here, no? Pero wala siya, hindi siya makita. But in the right side of your interatrial septum, there is a depression, no? Naa siya depression din ha. You call that your foramen ovalis. This depression is actually your foramen ovale. No, if you remember, foramen ovale is the opening between, no, it's a hole between your right atrium and left atrium. So in a fetal heart, no, or embryonic heart, there is actually an opening here, which pushes blood directly, no, from right atrium to left atrium, no, during fetal period. This mechanism surpass or bypasses the lungs, no? So this one, as the baby is born, this slowly closes in time and it creates a depression, no, in that area, and so you call that your foramen ovalis. The heart also has two ventricles, that is your right ventricle and your left ventricle. The blood in the right ventricle comes from your right atrium, no? Pag pump ng right atrium, it moves to the right ventricle and the blood here flows towards your pulmonary trunk, okay? That's where your pulmonary artery branches and delivers the blood to the lung for gas exchange. And then babalik siya by way of your pulmonary veins, no? Carrying oxygenated blood towards your right atrium, and the right atrium pushes your blood towards the left ventricle. So the left ventricle receives its blood from your pulmonary veins, and then it pushes the blood towards your aorta. No? So this aorta is a great vessel that carries the blood, no, to supply the entire body. Okay, and then these two ventricles are separated here by your interventricular septum. So if you see in this picture, the walls of your left ventricle is thicker than the walls of your right ventricle. So it is actually thicker because your left ventricle, it has stronger contractions, no? Because it pumps blood through the systemic circulation. So kailangan malakas siya in order to reach the entire portions, no? Upper portions toward the lower portions of the body. So let's discuss the valves of the heart. There are 4 valves of the heart. The first valves we will discuss are your atrioventricular valves. No, dalawa sila. You have one in the right and you have one in the left. Okay, your atrioventricular valves, also you call them as your AV valves. These are cusp or flaps that ensure blood flows from the atria into the ventricles, preventing blood from flowing back into the atria. No, so once the atrium or your atria pumps blood towards the ventricles, no, hindi na sila mag-backflow because the valves would close automatically here, no, preventing the backflow. So you have two, like I said, in the right, between your right ventricle and your right atrium and right ventricle is your tricuspid valve, okay? It's tricuspid, so here you see, here it's tricuspid, tri because it has 3 cups, no? And on the left is your bicuspid valve, also known as your mitral valve, no? Bicuspid because it has 2 cusps. So this one prevents um, the backflow of blood, no, from your left ventricle to your left atrium. Now, your ventricles are muscular tissues, okay? So you have certain muscles there. That's your papillary muscles, okay? These are cone-shaped, no? Muscular pillars. So yan yung maliliit. No, they are cone-shaped. You see those, no? And these are attached to the cusp, okay? Remember the cusp, we have a tricuspid valve and a bicuspid valve, no? Made of 3 cups and 2 cusps, respectively, yung AV valves natin. So all these papillary muscles are attached to your cusp by a thin, strong connective tissue, no? You call them your chordate tendineae. So yung parang string-like tissues dyan, thin but are strong, no? They connect your papillary muscles to the cusp or to the cusp of your AV valves. So these muscles contract, no? Once these muscles contract, and when the ventricles also contract, this prevent the valves from opening, no? Kasi pag contract niyan, the opening into the atria will be pulled by your chordate tendineae attached to the cusp. That's why, so pag contract niya, it will pull also this cusp here, making it close, no? So once it contracts, it is pulled by this chordate tendineae and papillary muscle, and the cusp close upon contraction. So wala talagang backflow, no, of blood from your ventricle to your atrium. The other two valves of the heart are what you call your semilunar valves. No? They are called semilunar because they are half moon shaped. Okay. So this valve is positioned between each ventricle and its associated great artery. Okay. So you have two great arteries, no, your aorta and your pulmonary trunk. So this valve associated with your aorta is your aortic semilunar valve, no, here. And the other one is associated with your pulmonary trunk, which is your pulmonary semilunar valve. So there's are three pocket-like semilunar valves, okay? The contraction of your ventricles will push the blood towards this great arteries, no? So that's why the high pressure, no, from the contraction of your ventricle will also push these valves to open, no? So the blood flows to the great arteries from your right ventricle to the pulmonary trunk, from your left ventricle to your aorta. So like any other organs, your blood has its own supply, and this is provided by the coronary circulation. The coronary circulation consists of blood vessels that carry blood to and from the tissues of the heart. So you have major vessels in this coronary circulation, and usually these vessels are located, no, in grooves or sulcus seen at the surface of the heart. So we will see what are these grooves or sulcus seen, no, at the surface. Here you would find coronary sulcus, no? This one, coronary sulcus. Okay, this part here, no, this is this is running obliquely, no, around the heart. It separates the atria from the ventricles. Then you will see another two grooves that extends inferiorly from this sulcus. Okay, those grooves you see are dividing your two ventricles. So in the anterior portion, you will see an anterior interventricular sulcus, and in the posterior portion, you will see your posterior interventricular sulcus. So this is the posterior portion, okay? But on the anterior portion also, you will see another sulcus there. So what are the vessels that supply the heart tissues? These are your coronary arteries. So you have a right and left coronary artery, but the one seen here is only your right coronary artery, no? So you have right and left coronary arteries, and they exit above, um, exit the aorta just above the point where the aorta leaves the heart. So in this picture, you will see your right coronary artery. Now, if we see the sulcus here, no, your coronary sulcus, the major vessel that is passing through this sulcus is your great cardiac vein, okay? And on the posterior interventricular sulcus here, the vessels that runs through here, okay, actually you will have the middle cardiac vein and an posterior interventricular artery. So you have a vein and artery running through the posterior interventricular sulcus. So let's review the groups and sulci, no? Summary of what we discussed earlier. You refer this to the picture. These are the major grooves and sulci you see in the surface of the heart. You have a coronary sulcus. This runs obliquely around the heart, separating the atria from the ventricles. And here are the associated vessels. The artery that runs through it are your right and left coronary arteries, and the vein associated with it is the great cardiac vein. Now there are two more grooves coming from the coronary sulcus, and they extend inferiorly towards the apex of the heart. No? These two grooves divide between the right and left ventricle. So you have one that is anterior and the other is a posterior interventricular sulcus. So what are the vessels associated with the anterior interventricular sulcus are your great cardiac vein and your anterior interventricular artery. While for your posterior interventricular sulcus, the associated arteries and veins are your middle cardiac vein and a posterior interventricular artery. So refer to the picture earlier and locate all these vessels, no? Associated vessels in the mentioned sulcus and grooves. So you have your right and left coronary arteries, okay? So your right coronary artery, this one, is usually smaller compared to your left coronary artery, and this does not carry as much blood as your left coronary artery. So the majority that supplies the blood to your heart tissues is the circulation of your left coronary artery. Now, there are three major branches, no, of your left coronary artery. First, we identify your anterior interventricular branch. So this one, okay? So this is your left coronary artery. This is the first major branch. That's your anterior interventricular branch. Okay, this branch of your left coronary artery is also known as your left anterior descending artery. So it extends inferiorly into your anterior interventricular sulcus, no? I mentioned earlier ano yung mga associated vessels with your grooves and sulci. So actually, this is on the anterior interventricular sulcus. However, it has a more popular name. It is more known as your left anterior descending artery, no? Or your LAD. This artery supplies most of the anterior portion of the heart. Now, the second major branch of your coronary artery is your left marginal artery. So, from left coronary artery, that's your left marginal artery. This supplies the lateral, no, wall of your left ventricle. And the third major branch is your circumflex, okay? Circumflex artery. This extends to the posterior side of the heart into the coronary sulcus. Now, the branches of your circumflex artery also supply much of your posterior wall. So your circumflex artery, it goes around, no, behind, supplying most of the posterior tissues of the heart. The cardiac cycle involves a predictable pattern of contraction and relaxation. Before we discuss, let's define these terms first. When you say systole, that means contraction, no? To contract. And diastole would refer to dilation or relaxation. So when you say atrial systole, this means contraction of your atrial myocardium. So that's your right and left atrium contraction. And when you say atrial diastole, it means relaxation. So with regards to ventricular pumping, no, ventricular systole would also refer to contraction of both your right and left ventricles, and your ventricular diastole is the relaxation of your both ventricles. Let's take a closer look on your cardiac cycle. Okay, so atrial systole, we know that systole is contraction. So this is a contraction of both your right, left atrium. Now, what does it say here? That your atrial systole is also the active ventricular filling. Okay, why? So this is your right and left atrium, no? Once they contract, they push out the blood towards your ventricles. So that's why it's active ventricular filling. And in order for your ventricles to be filled up, no, it should be relaxed, no, in order to accommodate the blood coming in. That's why this is also known as ventricular filling. No? Your atria contract, increasing the pressure here, no? And they complete ventricular filling, no? Habang relaxed ang ventricles. So once the ventricles are filled up with blood coming from your atria, no, we go to the next cycle, which is your ventricular systole. This is also known as the period of isovolumetric contraction. Okay, in this phase now, your both atria are relaxed. No, since they are relaxed, they are filling up also with blood coming from your veins. No, while your ventricles are getting ready to contract. And so this time, your valves, your atrioventricular valves are closed so that when your ventricles pump, it won't backflow, no? Yung right ventricle mo would go to your pulmonary circulation as it contracts, and your left ventricle, as it contracts, will deliver blood to the systemic circulation. So at this time, the semilunar valves are still closed and they remain closed and during this period. So as you see, all of the valves in ventricular systole or period of isovolumetric contraction are all closed. Okay. So what else happens, no, after this period of isovolumetric contraction? But still, this is the period also of ventricular systole. This is now the period of ejection. So these both are happening during ventricular contraction, no? You have a period of isovolumetric contraction wherein all your valves are still closed. But in the period of ejection, due to continued ventricular contraction, this will increase the pressure in your ventricles, and this will cause the blood to be pushed out of the ventricles, causing your semilunar valves to open. Your semilunar valves are the valves from your right ventricle to your pulmonary artery. No? That's your semilunar valves. So after the ventricle push out the blood, that's the period of ejection. Now your ventricle relaxes. That's the period of ventricular diastole, also called as the period of isovolumetric relaxation. So as these ventricles, they would start to relax, no? At the beginning of your diastole, the blood will flow back from the aorta and your pulmonary trunk. So babalik sila, no? Pagka-push yan, for example, pulmonary trunk, no? Once the blood is pushed out, no, because of high pressure, pag-push niya, at the beginning of your diastole, this blood would suddenly flow, no? Pabalik. However, this time, the semilunar valves are already closed. Okay? So that means, no, closed na sila. So even if the blood flows back a bit, hindi na sila backflow towards to the ventricle. No? As you see, in the period of isovolumetric relaxation, with the similar to isovolumetric contraction, all the valves here are closed. After this one, there's another phase of your ventricular diastole, also called as the passive ventricular filling. So as they relax, they would also slowly start, no? Yung AV valves would open. And now your AV valves are your atrioventricular valves, no? These are the valves in between your atrium and ventricles. So the next phase of period of isovolumetric relaxation is the passive ventricular filling, no, which is also under ventricular diastole period. So this one, the valves start to open. However, semilunar valves are still closed, no, and then the blood coming from your atrium would also fill the chambers of your ventricles. Okay. Most of the ventricular filling is accounted, no, in this phase, no, the phase of passive ventricular filling. So as the passive ventricular filling is happening, no, which is accounting for the majority of the blood, no, filling in the ventricles, your atrium would start now to build up its pressure, okay? And this will lead to your atrial systole or your active ventricular filling. So here, upon build-up of the pressure inside the atrium, no, they will contract in order to pump the blood. And when they contract now, your AV valves will start to open, and the filling of blood will be filling of blood to your ventricles now will now happen. So this is in addition to the passive ventricular filling. And when that happens, no, as your atria start to contract, then your ventricles would also have to relax so that it can accommodate blood filling.